Electrical engineer job role, practical experience guidelines and AI contribution. Electrical engineers are the backbone of modern infrastructure, from renewable energy systems powering our cities to AI-integrated control systems streamlining industries. Their work shapes our future, whether designing cutting-edge electrical systems or ensuring their seamless operation. Electrical engineers play a critical role in innovation. Join us to explore the exciting world of electrical engineering, where human ingenuity meets AI-driven technology, creating a more efficient, sustainable, and connected world. Job description. An electrical engineer designs, develops, tests and supervises the installation of electrical systems, also equipment used in power generation, distribution, control systems, telecommunications as well as consumer electronics. Their work spans multiple industries including energy, automotive, aerospace, telecommunications. In recent years, the role has increasingly focused on integrating AI and automation to improve efficiency, also reliability in electrical systems. Industry profile. Electrical engineers work in various industries, such as renewable energy, robotics, electric vehicles, telecommunications, and smart cities. The demand for engineers skilled in AI-driven electrical systems, IoT, Internet of Things, also renewable energy is rising rapidly. Engineers must stay updated on emerging technologies, particularly those involving automation, energy storage systems, as well as smart grids. Key responsibilities. Design and development. Create electrical systems, circuits, and hardware components to meet client specifications, also regulatory standards. Project management. Oversee electrical engineering projects from conception to completion, ensuring deadlines, budgets, as well as safety protocols are met. Research and innovation. Engage in ongoing research to improve electrical components along with systems, particularly in the fields of renewable energy, AI-driven systems, and automation. Testing and maintenance. Conduct performance tests, troubleshoot, including provide maintenance for electrical systems to ensure reliability and efficiency. Compliance. Ensure systems comply with industry standards, safety regulations, also environmental policies. AI integration. Work on integrating AI as well as automation into control systems, optimizing performance, also predictive maintenance in industries like manufacturing and energy. Collaboration. Work with multidisciplinary teams, mechanical engineers, software developers, along with data scientists, especially when implementing AI and smart systems. At a glance. Your interest. Strong interest in electrical systems, renewable energy, automation, AI, and problem solving. Entry qualification. Bachelor's degree in electrical engineering, with further certifications in AI, automation, also renewable energy systems highly beneficial. Lifestyle. Typically office-based with site visits for installations as well as inspections. The work can be demanding during large projects or system failures. Location. Opportunities worldwide, particularly in industries like renewable energy, telecommunications, including smart cities. The realities. High responsibility for system reliability and safety, need to stay updated with the latest technology trends along with standards in the industry. Soft Skills Guide. Ability to work effectively in teams composed of professionals from various engineering disciplines. Strong leadership and project management skills to lead technicians, also developers. Highly analytical and logical approach to designing, testing, as well as troubleshooting complex electrical systems. Advanced IT skills, including proficiency in simulation software, automation tools, and control systems. Commercial awareness to deliver cost-effective solutions that meet customer needs along with comply with regulations. Effective communication to explain technical details to non-experts and collaborate with cross-functional teams. Career path. Trainee engineer. Start as a trainee in an electrical or power systems company, learning fundamental concepts. Junior electrical engineer. Gain hands-on experience with design, testing, and maintenance tasks in various sectors. Electrical systems analyst. Specialize in analyzing, also optimizing electrical systems, often incorporating AI-driven solutions. Senior electrical engineer. Take on larger projects, managing teams, as well as designing complex systems. Technical architect. Develop high-level electrical designs including provide expertise for large-scale projects. Lead engineer/consultant. Led projects across industries, offering specialized expertise in AI and electrical system integration. Chief engineer/director. Oversee the electrical engineering function for an organization, setting strategy, also innovation roadmaps. Related careers. Power systems engineer, focuses on the generation and distribution of electrical power, with emphasis on smart grid technologies. Automation engineer, specializes in designing automated systems for manufacturing or process control, integrating AI where applicable. Telecommunications engineer, designs as well as maintains systems for communications, often involving AI-driven signal processing. IoT engineer, works on integrating electrical systems with IoT technologies, especially in smart cities and connected devices. Renewable energy engineer, specializes in the development of systems for solar, wind, also other renewable energy sources, often using AI for optimization. Here is a list of practical experiences for electrical engineers and how to learn them with the latest or updated technology. Circuit design and simulation. Practical experience. Design and simulate complex electrical circuits for various applications, from consumer electronics to industrial power systems. How to learn. Software tools. Master industry standard tools like MATLAB/Simulink, LT-Spice, Multisim, or OrCAD to design also simulate circuits. Online courses. Enroll in courses on Coursera, Udemy, or edX that focus on electrical circuit design as well as analysis. Hands-on projects. Use platforms like Arduino or Raspberry Pi to design along with build physical circuits, simulating them first and then implementing real-world projects. Power systems design and smart grid technology. Practical experience. Work with large-scale power systems, focusing on smart grid technologies that incorporate renewable energy sources and AI-driven automation. How to learn. Software tools. Learn tools like ETAP or PowerWorld to simulate also optimized power systems. Industry certifications. Get certified in smart grid technology through programs from the IEEE Power and Energy Society or other institutions. Renewable energy integration. Study renewable energy integration into power grids via specialized courses on platforms like IRENA, focusing on the future of AI-driven smart grids. PLC programming and automation. Practical experience. Program programmable logic controllers, PLCs, for automated systems in manufacturing, energy distribution, and control systems. How to learn. Software tools. Gain proficiency in tools like Siemens TIA Portal, Allen Bradley Studio 5000, or Codesys for PLC programming. Online courses. Enroll in courses on platforms like Udemy, LinkedIn Learning, or Automation Academy that teach the basics of automation, also PLC programming. Hands-on labs. Use training kits such as the Siemens S7-1200 Starter Kit or Allen Bradley Micro 820 to practice PLC programming along with develop real automation projects. Embedded systems and IoT integration. Practical experience. Design and implement embedded systems for IoT, Internet of Things, devices, integrating sensors, actuators, and AI-driven controls. How to learn. Software tools. Work with development environments like Keel, Embedded C, Arduino IDE, or Platform I/O. Hardware kits. Build hands-on projects using ESP8266, STM32, or Raspberry Pi for IoT solutions. Courses and certifications. Take IoT specialization courses, like IoT Specialization by Coursera, also certifications in embedded systems by organizations like ARM or Texas Instruments. AI and machine learning for predictive maintenance. Practical experience. Implement AI and machine learning algorithms to predict failures, also optimize maintenance schedules for electrical equipment. How to learn. Software tools. Familiarize yourself with AI platforms like TensorFlow, PyTorch, or MATLAB for predictive maintenance applications. Online learning. Courses like Machine Learning for Predictive Maintenance on Coursera or edX can guide you through practical applications of AI in engineering. Industry certifications. Get certified in AI for industrial applications from platforms like Siemens MindSphere Academy or IBM Watson IoT. Control systems engineering. Practical experience. Design, analyze, and optimize control systems for industries such as automotive, aerospace, also robotics, often integrating AI for real-time adjustments. How to learn. Software tools. Master control systems software like MATLAB/Simulink, LabVIEW, or SCADA for automation as well as control systems. Online courses. Take control systems engineering courses available on edX or MIT OpenCourseWare. Hands-on projects. Develop small-scale control systems using Arduino or Raspberry Pi, focusing on controlling motors, sensors, including other components. Renewable energy systems. Practical experience. Design and implement systems that generate, store, also distribute renewable energy, such as solar panels, wind turbines, as well as battery storage solutions. How to learn. Software tools. Use software like Homer, PVSYST, including RET Screen for simulating renewable energy systems. Certifications. Pursue certifications in renewable energy systems from organizations such as NABCEP, North American Board of Certified Energy Practitioners, or IRENA. Online learning. Take online courses from platforms like Udemy, Coursera, or IRENA on renewable energy technologies along with energy storage solutions. Electrical safety and compliance. Practical experience. Understand and implement electrical safety standards, also compliance protocols, particularly in industries requiring rigorous safety standards such as healthcare as well as energy. How to learn. Industry standards. Study and apply standards like NFPA 70E, OSHA regulations, including IEEE 1584. Certifications. Get certified in electrical safety compliance through programs offered by NEC or OSHA. Workshops and seminars. Attend workshops along with webinars on electrical safety from organizations such as NFPA and IEEE. High voltage systems. Practical experience. Design and maintain high-voltage electrical systems, such as those used in transmission lines, also substations. How to learn. Software tools. Master tools like PSCAD or PowerWorld Simulator for simulating high-voltage networks. Training programs. Enroll in high-voltage electrical engineering courses, which are often available through ABB or Schneider Electric. Practical experience. Work on internships or practical field assignments with utility companies to gain hands-on experience in high-voltage installations. Energy storage systems. Practical experience. Design and optimize energy storage systems such as lithium-ion batteries, also advanced energy storage technologies for renewable energy as well as electric vehicles. How to learn. Software tools. Learn tools like Plexos or Homer for energy storage system simulations. Certifications. Pursue certifications in energy storage from providers like IRENA or Tesla Energy. Practical projects. Build energy storage prototypes using open-source platforms or participate in specialized renewable energy projects. These practical experiences will provide a solid foundation in electrical engineering, preparing professionals for a future driven by AI, automation, renewable energy, and smart technologies. 8. A contribution to autonomous transformation for electrical engineer role. Thank you for listening. For more information related to career path, job role or description follow our channel Career Quest.